Hello and welcome back to the Arch Linux for Content Creators series. In this video, we're going to be discussing how to start gaming on Arch Linux for those of you who want to stream or record gameplay. Before we start though, you may have noticed my virtual environment looks a little bit different from the last video. That's because I'm now recording this entirely within my VM instead of just recording the VM window on my host machine. To do this, I've passed through my AMD GPU from my host Arch Linux to my VM so that I'll be able to actually open and play games for demonstration purposes. We're not going to be covering how to do this today, I just wanted to mention this for full transparency. With that out of the way, the first part of this video will be fairly short and we'll cover how to install and configure Steam to run games. The second part is going to be quite a bit more involved and focus on how we can optimize the performance of Steam and our PC as a whole. Without further ado, let's get started by installing Steam. So first, let's go ahead and open up Console. And actually, I'm going to go ahead and pin this to the taskbar because it's very annoying to keep having to search this up. And let's go ahead and open it. All right, so the command that we're going to be using to install Steam is the following. So this command will install Steam, as well as some font dependencies that Steam will need to display text properly, and a 32-bit package that we probably already have, but will be necessary to ensure downloads from the Steam servers work properly. Let's go ahead and hit enter, type in our password. So once that finishes, we can go ahead and launch Steam. I'm just going to launch this from the terminal since it's right here in front of me. I've already updated Steam and logged in prior to this recording to save some time, but on a fresh install, the Steam launcher will start updating itself before it opens. Once it's done, log into your Steam account as you normally would. Now my Steam already opened up in this window off to the side here. So now that we're logged in, we'll need to make some adjustments to Steam so that we can run Windows games on Linux. Navigate to the top left corner, select Steam, Settings. Navigate to the Compatibility tab in this menu, and we'll see this option, Enable Steam Play for all other titles. We want to make sure to enable this. This is what's going to actually let us play Windows-based games on Linux. It'll ask you to restart once you click that, and so we're going to click Restart. So now that Steam's restarted, if we navigate back to that compatibility menu again through Steam, Settings, Compatibility, we'll see that we have a new drop-down menu in here that allows us to select different versions of something called Proton. Without going into too much detail, Proton is essentially a compatibility layer that converts Windows operations into commands that Linux can understand in real time. It's basically an extension of Wine developed specifically for the Steam client. We'll be discussing Wine a little bit more in the future, but for now, we don't really need to worry about it. Depending on the game you're playing, it may be beneficial to select a different Proton version. However, it's generally suggested to just use Proton Experimental, as it often has some additional patches that the other stable versions of Proton may not have yet. So that's what we're going to use for the time being. Select Proton Experimental, it'll ask you to restart again, so we're going to do that. Now Steam is finished rebooting, and it's been configured to play Windows games. But before we start loading our new Arch install with 40+ gigabyte games, we want to make sure that they will actually run first. Thankfully, there's a website that can tell us which of our games can run on Linux called ProtonDB. ProtonDB is a site where Linux users can submit their experience running Steam games through Proton and share any tips or tricks they use to get a game running or increase performance. Pretty much the only games that could be completely unplayable on Linux are games that use BattlEye or Easy Anti-Cheat. Mutahar, from Some Ordinary Gamers, recently did a pretty good video summing up the issues with Linux and anti-cheat, so go check that out if you haven't already. However, not all games using these anti-cheat engines are unplayable. Elden Ring and Dead by Daylight are both online games, for example, that run just fine on Linux and use Easy Anti-Cheat. However, some games like Fortnite and Rainbow Six Siege have actively taken a stance against allowing their games to run on Linux, or even on virtual machines for that matter, and will not function properly. If there's a game that you love but can't play on Linux, I'd highly recommend running a dual boot PC and keeping Windows just to play those specific games. It's not an elegant solution, but games currently unsupported on Linux due to their anti-cheat will likely never be supported. The way that I'm currently handling the issue of not being able to play some of the Windows-specific games that I like on Linux is to use a local or server-based game streaming service like Moonlight or GeForce Now to play the game on a different PC while streaming the output to my Linux machine. Before we start playing games, we want to make a couple of little changes to Linux to make sure that we have a consistent experience. If you play any FPS games like me, you probably know about the trick of disabling mouse acceleration on Windows to have a more consistent sensitivity. Linux also has mouse acceleration on by default, and unfortunately it can be a bit more difficult to disable than Windows. The Arch Linux Wiki has a more in-depth guide on how to adjust/disable mouse acceleration. But for a quick overview, here's how you'll disable this. Now first off, we want to know whether we're running on a Wayland or X11 server. If you're unsure which one you're running on, we can go ahead and open up the terminal, and I'm going to make a new tab here since I'm using Steam. And we're going to use the following command to check to see whether we're using a Wayland display server or we're using an X11 display server. So this will be echo. This is an environment variable called XDG session type. Now if we hit enter here, this will tell us what our XDG session type is set to. KDE is going to actually set this variable appropriately, and in my case, I'm using Wayland. However, if I was using X11, this would echo X11. So for Wayland, there is not one universal way to set or disable the mouse acceleration. This is going to be dependent on your specific desktop environment or window manager that you're using. But in KDE specifically, we can just go ahead and go to the system settings down here and mouse and touchpad. And you may have a couple different devices in the mouse menu. In my case, I have a graphics tablet and it's recognizing my keyboard as a device, as a mouse device for some reason. But the actual mouse I'm using is this Logitech G502. We'll select that, or whatever your mouse actually is. And you'll see right here, we have this option called pointer acceleration. Standard means it's on, none means it's off. You may also see this defined as flat or acceleration or something like that. We just want to make sure we use either the flat or the none profile. This will completely disable mouse acceleration in KDE or in Wayland. If you want to, you can also go ahead and play around with your pointer speed. I like to leave my pointer speed at default. I find it's fine for navigating my desktop, and I don't get any sort of weird inconsistencies when I'm playing video games with it set to 0. You can also change your scrolling speed here, and some other options if you really feel like changing those. But for now, the only one that I care about is disabling pointer acceleration. After we hit apply, we can go ahead and close this window, and you'll probably notice your mouse is going to feel a little bit different. Now for X11, you can set the acceleration profile using X input per session, but for it to persist, you're actually going to need to create an X11 configuration file. To do this, we're going to add a new file using the terminal. So I'm going to do sudo nano /etc/x11/xorg.conf.d/40-libinput.conf. Now this command is actually taken straight from the Arch wiki page. It doesn't necessarily even need to be called 40-libinput.conf. You can call this whatever you want as long as it ends in .conf. So let's go ahead and enter. So basically X11 uses the libinput library to actually manage the mouse by default. So what we're going to add in this file is the following. So essentially what this file is going to be doing is it's going to find any device using the libinput protocol to control the mouse, and it's going to just set the Accel profile to flat, which is basically going to completely disable mouse acceleration. So once we've got the file looking exactly like this, we can go ahead and save it with Control-O in Nano and Control-X to exit. So now, if you're running X11, when you reboot your computer or reload the X server, this will take effect, and you'll notice that your mouse acceleration is no longer active. Now, once again, if you run into any issues with this or are confused on how this is supposed to work, you can go ahead and visit the mouse acceleration Arch wiki page for a little bit more in-depth guide on how to set this up. But just for a quick overview, this is how we're going to disable mouse acceleration. All right, now that we've got our mouse configured and we know what games we can actually run on Linux, we should be ready to start installing and running games in Steam. Installing Steam games on Linux is almost exactly the same as it is on Windows. However, you may notice that Steam downloads a few extra tools such as Steam Linux Runtime or Easy Anti-Cheat Runtime. In my case, I'm going to go ahead and test Silent Hill 2. So let me go ahead and go to my library, Silent Hill 2. Now I have not run this on this VM yet, so if we run into any issues, we'll get to solve them together. Now this game doesn't run natively on Linux, and so we're going to be using Steam Play and or Proton to actually get this working. And also this game's fairly resource intensive, which hopefully will make a good test to make sure everything is working well. All right, now when you run games occasionally on Linux, and this is Linux specific as far as I'm aware, you may be shown this window here that says processing Vulkan shaders. Basically what this is going to process all your shaders before you run the game. This can actually prevent micro stutters in the game whenever you actually run it. You'll notice you also have the option to skip or cancel. If you hit cancel, it's going to stop running the game, or you can skip processing the Vulkan shaders, and that'll actually go ahead and ignore processing those shaders. Sometimes these shaders can take forever to actually process, so sometimes it might be best to just go ahead and skip them. All right, so now as we can see, we're actually gaming on Arch Linux. Looks like our cutscene is working just fine. Frame rate's not too bad. I'm actually gonna go ahead and skip this cutscene. Now let's go ahead and walk around, and yeah, look at that. Pretty clean. Pretty smooth. All right, so yeah, as you can see, everything's working pretty well. I mean, Silent Hill is a pretty poorly optimized game, to be completely honest with you. I do have the resolution a bit lower than 4K, which is what my monitor actually is, but I want to make sure that this recording is actually smooth. Okay, let's go ahead and close out of this. All right, and there we go. We're now gaming on Arch Linux. Something once thought impossible can now be done in about the same amount of time it takes to go from a fresh Windows install, if you're good at following instructions. So if you're happy with that, then more power to you. You can go and tell everyone that you meet that you've got an Arch Linux-based gaming rig. But if you're like me, and you want to push your system to its maximum performance, gaming or otherwise, then please continue watching, because we're going to get into a little bit more of the technical configuration to make our PC run as fast as it can. So at this point, many games will run with performance equal to or better than Windows. Admittedly, this is mostly because Linux doesn't run 10 million programs in the background on boot like Windows does. Arch Linux was not specifically designed with gaming performance in mind though. In the next section, we're going to be doing some configuration to our system to ensure we get the best performance in whatever we're doing. On Windows, applications like GeForce Experience and MSI Afterburner offer overlays that display this information on top of your active application. Linux has a similar type of overlay called MangoHud, and that's what we're going to be installing right now. So let's go ahead and open up console again. and we're going to run the following command to install MangoHud. Alright, so now MangoHud is installed. To test that our MangoHud installation actually worked, we can use a program from the Vulkan Tools package we installed in the previous video, called VKCube. To enable MangoHud for a non-Steam program, we can set the MangoHud environment variable when launching the program. We're not going to be going over what environment variables are in this video, so for now we'll run the following command to display MangoHud on top of VKCube. That's going to be MangoHud, in all caps, equals 1. No space. So basically the environment variable we're setting is MangoHud, and we're changing its value to 1. And then we'll type in the command that we want to run that with, which is in this case VKCube. And this ran on the wrong monitor, but if I drag this into frame, we can see this little box, this little spinning cube. In the spinning cube, we can actually see this little overlay here that shows our GPU usage, our CPU usage, and our current frame rate using Vulkan. Now this is what the default installation of MangoHud is going to look like. It tells you a little bit about how your system is running, but more than likely you're going to want to go ahead and configure this to be a little bit more verbose. So MangoHud actually offers quite a bit of customizability, and we can customize it by directly editing the file .config/mangohud/mangohud.conf. However, a GUI exists to make editing this file a bit more intuitive, so we're going to install this as well. Let's go ahead and close out VKCube for now, and we're going to do sudo pacman-s GOverlay, and we're going to hit enter. Alright, so now we've installed GOverlay, which is a graphical interface to configure both MangoHud and VK Basalt. Right now, we're not going to talk about VK Basalt, but basically VK Basalt is a post-processing application that's pretty similar to Reshade. Again, for right now, we're not going to talk about that. The configuration is a bit more involved than I want to get into today. So let's go ahead and open GOverlay. That opens up the VKCube prompt that we just had. And actually, we can see this has already made some changes to our configuration and shows a little bit more information like the clock speeds, the power usage, the temperatures, and we can also see what our actual RAM usage is now. So if we move this out of the way, we can see we have a couple of different options here for presets. We can have a full preset. Actually, let me go ahead and expand this a little bit. So we've got the full preset, which if we click on that, it'll show us this. Now this gives us way more information, gives us information about each individual thread that's running, as well as our IO read-write speed. And other than that, most of this is about the same. We can see our FPS, our average FPS, and our 1% FPS, as well as some other stuff down here. Now this is if you wanted to see like absolutely everything about your system, you're doing a very thorough test. In our case, we're probably going to want to use something closer to basic, which is like what we just saw when we first opened GOverlay. And this tells us really everything that, in my opinion, I would need to know. Our percent usage, our temperatures, our clock speeds. This is really everything that we're going to care about. But if you want to go ahead and find something in between full and basic, we can go to the other tabs in GOverlay and customize how everything looks. So we can give the window a title if we want. We can change the orientation of the graph. We can change if there's borders, if they're rounded or not. We can change the background, change the font size. That's something I'm actually going to do real quick. This is a little bit large in my opinion, so I'm going to actually turn this down a little bit more, say 18, and we're going to save that. That's a little bit smaller, that's a little bit easier to read, and it doesn't take up quite as much of the screen. We can also change the position. If we want to put it in the top right instead of the top left, we can do that. Personally, I'm going to go ahead and leave most of this at default. I want to change the size, put the position back over to the left, and I'm actually going to get rid of the background because I don't really like the background. You can configure this however you want. On top of that, you can also configure some other things like limiting your FPS to not go above a certain range. You can color your FPS values at a certain point. You can also change the other metrics that are displayed. So say we want to see how much memory is being used, we can also add this. So basically you can go ahead and play with all this stuff and configure it to your liking. For now, I'm going to more or less leave this about the same. Once you're done making your changes, we can go ahead and hit save. Now that I know I've already saved all my changes, I'm going to go ahead and close out a GOverlay and VKCube. So now we've got MangoHud all configured, we can start using it in our Steam games. To do this, let's go back into Steam and we'll open up the Steam game that you want to add this to. In my case, I'm going to leave this as Silent Hill 2 since that we already know this is working. And we can right click on the game you want to choose, go down to properties, and you'll see in this general window at the bottom, we have launch options with a text edit box. Here we can specify commands or other programs we want to run when we click play on a specific game. To enable MangoHud, we're going to enter the following into the launch options. MangoHud %command %. Now, this MangoHud is actually a alias. We could also have put the same command we put earlier, which is MangoHud equals 1 if we want to specify the environment variable directly, but I find it's a little bit easier to just run this one. So you need to make sure that MangoHud comes before the %command part. Later on, we're going to be adding another command to this, but basically any Linux-specific application will come before the %command, and any game-specific options will come after the %command, such as -novid on Valve games. So we can go ahead and close this. There's no save button on this window. It just, as soon as we enter in our commands, it saves. So if we go back into properties, we'll see it's staying there. So let's go ahead and run Silent Hill 2 again. All right, so now we can actually see that MangoHud is in the top left corner, and it looks like I made the text just a little bit too small. And we walk around, we can see we're about 60 FPS. Just gonna do the same little rundown again with MangoHud running. Oh, a little bit of stuttering. But it seems to be running, you know, pretty well. It's hanging out around 60, sometimes going a little bit over, sometimes going a little bit under. But, you know, perfectly playable. And especially since this is at 1440p, I'm not complaining. So depending on how you installed Arch Linux, most of you will probably have the default Linux kernel. If you wanted to check, you can enter the following command into console to see your active kernel version. As we can see, my current kernel version is 6.13.8, and I'm using the Arch kernel, which is the just general default Arch Linux kernel. However, there are different versions of the Linux kernel that you can install that can offer various performance gains depending on how you use your system. The Linux kernel that I recommend you install for the best performance in gaming and audio applications is the Linux Zen kernel. This kernel is optimized for low latency and high responsiveness and is designed to be the best Linux kernel possible for everyday systems. You can read into how it differs from the main kernel on the Arch wiki, but for now I'm going to show you how to install it. To install the Linux Zen kernel, we're going to type the following commands. Now, anytime you want to install a specific kernel that is offered either in the AUR or in the actual Arch Linux repositories, you want to make sure you also include the headers package. It's very important. So we're going to go ahead and hit enter here, and we'll see it's going to download download the kernel, and then it's going to actually go ahead and build that kernel using mkinitcpio. And so this is basically going to add this kernel to our boot options in grub later on, but we're also going to have to update grub to use it. Assuming you're using a standard grub installation, we're going to enter the following command to add the kernel to the boot menu. As you'll see, it's found our Linux Zen kernel, and it's also found our Linux kernel. So when we reboot our computer, we're actually going to be able to see two different options in the advanced boot menu options. So once it's done, we can go ahead and save everything we have open, and we want to reboot our PC. So now that we've rebooted our computer, in our grub menu, we'll see Arch Linux and advanced options for Arch Linux. We're going to scroll down to advanced options for Arch Linux and hit enter. And now you'll see we have the two kernels that we have installed. For now, we're going to go ahead and ignore these fallback init ram fs options, and we're going to choose either Linux Zen or Linux. And because we want to make sure Linux Zen is working, we're going to go ahead and select this one, and we'll boot back into our Arch install. So now that we're back in Arch, if we go back to console and we enter in that command we entered earlier, uname-r, we can see now this displays the same kernel version, but instead of Arch, it displays Zen. That means we're using the Linux Zen kernel. Now, if you want this kernel to be the default every time you boot, we need to edit the grub configuration file. To do this, we'll use sudo nano/etc/default/grub. Enter in our password, and we're back in our grub file. Once again, this should look familiar to you, but you may not know exactly what everything is doing in here. For right now, we're just concerned about this first entry here, grub default. Now this is basically going to tell grub to always use the last option that we manually selected in the grub menu. So if we want to always use Linux Zen, we're going to change this value from 0 to 1. You can also change your timeout if you want, if you don't want to wait 5 seconds for the grub menu to automatically boot. I usually change this down to 3. If I'm booting up my computer, I'm usually sitting right in front of it. I don't need to wait 5 seconds for it to auto select. So once you're happy with those changes, we can go ahead and save the file with Ctrl O and Ctrl X. So we're not quite done yet. Because we made changes to the grub configuration file, we have to regenerate the actual grub config. So once again, we're going to run sudo grub mkconfig-o/boot grub.cfg. And so this will have the exact same output as it did previously, but if we go ahead and reboot our PC, and we'll see that actually when we rebooted, it immediately went to that advanced options, and then it selected the Linux Zen kernel. And we go ahead and open up console again and run that uname command, we should see the Linux Zen kernel. So the next configuration that we're going to do is Steam specific. This is recommended in the Steam Arch Wiki page, and it recommends changing a sysctl variable to improve stability in some games. To do this, first we're going to open up console, and we're going to do sudo nano/etc/sysctl ctl.d/80-game-compatibility.conf. The way that any of these configuration files work, the number is basically the priority and the name can be whatever you want. It's generally recommended to put a good descriptive name, kind of like a variable in programming. You want to make a variable that kind of documents itself. You don't necessarily want to make it var1 or conf1. That doesn't really tell you anything about what it does. Anyway, rant aside, let's go ahead and open that up. And in this file, we're going to have one line, and it's going to say vm.max_map_count equals 214748364 That's basically just going to give us the maximum count of VM maps. And so we just want to make sure that we have basically full range of what we can use. I don't know 100% what this does, but if it's recommended in the Steam Arch Wiki, it's probably beneficial to do. So we're going to do Control-O, Enter, Control-X. Next, we're going to install Gamemode. Gamemode is essentially a program that configures your CPU to temporarily run a few optimizations that makes the game run better with better performance. Typically, it does this by setting your CPU governor to performance mode and setting your game to a higher priority than other applications. However, we can also configure it to do some other things in the background for further optimization. To install this, we're going to run the following command: sudo pacman-s gamemode lib32 gamemode. All right, let's clear that out. Now to actually let Gamemode have full permissions, we need to add our current user to a newly created group called Gamemode. So to do this, we're going to use sudo usermod-a G Gamemode, and then whatever your username is, which in my case is just user. And so now if we use the groups command, groups user, we should see our user is part of the Gamemode group. So now we can actually start configuring the optimizations that Gamemode uses. To do this, we'll need to create a file called gamemode.ini. This file can be placed in a few different locations, but to give it the highest permissions, we're going to place this file in /user/share/gamemode. This package doesn't come with an example file by default as far as I'm aware, but the GitHub page provides a well-documented example file that we can use as our base. We're going to go ahead and navigate to the Gamemode GitHub page. So here we are at the Gamemode GitHub page, and we're going to go ahead and scroll down until we see the configuration section. And in here, we're going to see a link to the example gamemode.ini file. I'm going to go ahead and middle mouse click on this to open a new tab. And here we can see the example Gamemode file. It actually has comments telling you what everything does. It doesn't have every single possible value for these, and you may need to look up what some of these do, but this file will give you a general idea of all the configurations that you can actually apply using Gamemode. So we're going to go ahead and download it with this button on the top right, download raw file, and just save it in our downloads. Now that that's downloaded, we can go ahead and open it with our text editor. We don't need to run this as sudo because it's just in our downloads, so nano, and we're going to go downloads/gamemode.ini. All right, so now we've got that file open. Now actually, I'm going to go ahead and leave most of these options exactly the same, except I'm going to go all the way down to the bottom here to the custom section. I've recently discovered that this can be very helpful for getting just a tiny bit of extra performance based on your desktop environment or your window manager. Many X11 based desktop environments come with compositors, which basically add nice little animations and effects to your desktop. They can sometimes use up unnecessary resources, especially when you're playing games. Having an active compositor while gaming can sometimes add a very slight microstutter or delay that might not make a significant FPS difference, but can definitely make the gameplay feel a little bit off or just a little bit uncomfortable. So the custom section of this script can allow us to automatically enable and disable our specific compositor when our game opens and closes, giving us somewhere between a very slight performance boost and a significantly smoother gameplay experience. Now, if you primarily run under Wayland, this isn't going to help you at all, as Wayland requires a compositor to function. You can't disable it without disabling Wayland. But if you run KDE under X11, or like me, use a window manager based in X11, awesome window manager in my case, then this can give you some extra performance for free. For KDE in X11, we can add the following lines to gamemode.ini to disable kwin compositor when starting game mode and re-enable it when closing. In my case, I use PyCom with Awesome Window Manager. So to toggle PyCom on or off with game mode, I use the following configuration in my gamemode.ini. If you use something else, look into your documentation to figure out how to enable/disable your compositor via the terminal, and adjust the start and end parameters accordingly. Now, because I'm using KDE and Wayland, I'm actually not going to use this section at all, but for those of you using X11, this can be very beneficial. Now that we're happy with our configuration, we can go ahead and save it with Control-O and Control-X to close it. And now we can use the move command to move this file from our downloads to the appropriate location. So to do that, we're going to use sudo, as we need admin permissions to move to anything basically that isn't our user folder, mv for move, and we're going to move the file downloads/gamemode.ini to /user/share /gamemode/dot. In my case, it looks like the Gamemode folder doesn't actually exist yet. So let's go ahead and make that first. And now let's go ahead and try that command again. If we clear that out and we change to user share Gamemode, there should be one file in there and it should be that gamemode.ini file. And if we print that to the console, look at that, that looks pretty familiar. So there's one more thing that we need to do to get Gamemode to run successfully. So I'm going to go back to my home directory. So to enable Gamemode, we're going to have to enable the Gamemode system service file. To do this, we're going to use systemctl --user enable --now Gamemode. So this is going to enable the system service Gamemode, which is the Gamemode daemon, however you like to say it. And it's going to run on boot now. So we don't have to worry about this running again. That's what the enable does. And the --now flag enables it right now. So if we check the status of that system service using systemctl --user status Gamemode, we can see that this is active and running. And because I'm running a VM, it's going to have a bunch of errors that it's like, oh, I don't know where this specific CPU thread is. That's because I'm handling my CPU governor in my host machine. It's not really controllable by my VM. These are issues due to my specific configuration. You shouldn't see a bunch of errors. You should just see this started Gamemode line. So let's go ahead and clear that output. And so now we can go ahead and test this without running a game. To do that, we're going to use the command gamemode -t, and it's basically just going to run a bunch of tests to make sure Gamemode works. Now, again, I'm probably going to see some errors because I'm running in a VM, but ideally, if you're running on an actual computer, you shouldn't have any sort of issues, and every section in here should just say passed. But in my case, there's some issues. If you do happen to have any sort of errors with Gamemode, read the errors and try to figure out through Googling what might be the issue. So assuming everything is running correctly, we can now safely use Gamemode with our Steam games. To automatically enable Steam mode when running a game, we'll need to open up Steam again. So let me go ahead and do that. And we're going to go back to our library and navigate to the game that we want to add this onto. Once again, I'm going to use Silent Hill. We're going to right click properties, and we still got this MangoHud configuration in here. And next to it, we're going to add the following command, Gamemode run, all one word. So you can place the Gamemode command either in front of or behind MangoHud, it doesn't really matter, but you need to make sure that both of these commands are to the left of the %command % option. Now, unfortunately, this configuration is going to need to be done on an individual game basis. So while these properties are open, you may want to copy the launch options and go ahead and paste it to any other games you may want to use. So for instance, if I want to use it on web phishing, just paste it in here. And you're going to have to do that for every single game that you want to optimize, basically. It's annoying, but I don't know of any other way to automate this to affect every game in your Steam library and only the games in your Steam library, not every single application running on your computer. So now that Gamemode is ready to go, let's talk about optimizing our desktop as a whole. Similar to Windows, Linux has different power profiles that it can use to run under different conditions. However, these aren't quite as easy to configure as they are on Windows, and will require you to either modify system configuration files or use an external application to do this for you. But the system configuration method is a better approach for a set it and forget it way of handling performance tweaks. The application we're going to be using is called CoreCtrl, and this application allows you to configure your CPU and GPU power profiles and get maximum performance out of your hardware. To install CoreCtrl, we're going to run another command in console, and that command is sudo pacman -s CoreCtrl, all one word. All right, now once that's installed, we can find it in our application menu, or we can type CoreCtrl in the terminal and press enter. Now I'm just going to go ahead and select it from the application menu just to switch things up. And CoreCtrl is going to need root permissions. So to do that, we're going to have to enter in our root password and hit OK. So now when that opens, we're greeted by the homepage for this software. So there's two main tabs at the bottom of this application, Profiles and System. Profiles is where we're going to save different configurations and can activate them manually or configure them to run automatically with a specific program. The System tab will show us detailed information about our hardware and about the application itself. So if we click through the tabs on here, we can see this is the CoreCtrl, this is information about CoreCtrl. We can see what our kernel version is, what our graphics driver version is, in my case, Mesa, and we can see some information about our graphics card and about our processor. So back in the Profiles tab, we can click on the pre-existing global profile to edit it. In this window, we can see some graphs showing the current performance of our GPU. Underneath the graph, we have options to control our GPU fans and performance. For now, let's leave the ventilation at automatic and select Advanced in the performance mode dropdown. Now you may see some different settings than what I have here. Once again, I'm running in a virtual machine and I have a lot of this configuration already configured on my host machine. So it's going to look a little bit different for me than it will for you. But I'll show a picture here of how this normally looks on my host machine. The main settings in this window that we will worry about now are power limit and power profile. This menu is also where you configure a potential overclock on your GPU, but we're not going to be covering that today. For maximum performance, without playing with our clock speeds, we want to set our power limit to the maximum value, and we want to set our power profile to virtual reality. You can play around with the different options and power profiles listed here, but I found that the virtual reality power profile gives the best performance. Let's go ahead and apply these changes at the top right by clicking apply. After we do that, the buttons at the top change to save and restore. If we choose the save option, this will load this profile every time we open up CoreCtrl. If we find that we have some sort of issues with our current configuration though, we can select the restore button to put it back the way it was. But in this case, we do want this to at the very least have the max power limit and the virtual reality power profile. Let's hit apply and we'll save it. We've now optimized our GPU performance so that it will run at max performance in all instances, not just when we're playing games. Now, if you're running games with the Gamemode command, the options in the CPU tab will already be handled on each game you run the command on. However, if you want your system to run at maximum performance regardless of whether you're in game or not, then continue on to the CPU section. You'll notice the only option we have in here for CPU is to change the governor. The CPU governor essentially tells Linux how much to bias our CPU frequency to either save power, provide maximum performance, or let the OS decide what it thinks it needs. By default, Linux uses the schedule governor, which scales the CPU frequency based on system demand. For the fastest response time and to use basically the highest CPU frequency available at all times, we're going to set this to performance. Now hit apply and save. We've now configured CoreCtrl to optimize our hardware for maximum performance when CoreCtrl is open. It should be noted that these values will not automatically apply until we open CoreCtrl. So it may be worthwhile to start up the application on boot so you don't forget to do this later. Go ahead and close out of CoreCtrl for now. First, if you're on KDE, you can go into your system settings. We can scroll down to the bottom and you'll see the auto start option. Click on that. Here we can add and remove applications we want to start up when we log in. To start CoreCtrl at boot, we can select add new at the top right and select location in the drop-down menu. Now in this window, we can go ahead and search core and that'll show CoreCtrl. It doesn't matter which one you pick. These are the same application. It just falls into two separate categories. So I'm going to click the top one and hit OK. Now you'll see that the application has been added to the auto start menu. If you aren't on KDE, we can manually add this program to our auto start through the terminal. So I'm going to go ahead and delete this entry real quick and close out of this. This is a bit more of an advanced way of doing it, but both ways are going to do the same thing. First, we're going to open up console again, and we're going to navigate to user share applications. This directory is where we're going to save all of our installed package launch shortcuts. In Arch Linux, these are called .desktop files and contain most of the applications that appear in your application launcher. We can list the files in the folder with ls-l to display them in an ordered list that's a bit easier to read. Now, as you may have noticed, some of these applications aren't named exactly as they appear in the application launcher. If you have a bunch of applications to look through, you can use another command to significantly trim down the list. In our case, we're looking for CoreCtrl. So we'll use the following command to find it while already in the user share applications directory. So we'll type in ls-l and we'll use what's called the pipe command, which is done by pressing shift and / on US keyboards. And then we're going to type in grep or grep and space CoreCtrl. So now you'll see we have trimmed that huge list into just one entry. So essentially what this command is doing is it lists all of the files in the directory, takes that output, and then puts it into the grep command, which is going to search the output for the provided string, which in this case is CoreCtrl. So now that we've found it, we can see the full name of this file is org.corecontrol.corecontrol.desktop. So now we want to make sure this file opens when we log into our user account. To do this, we want to copy this file to our auto start directory located at home directory.config autostart. We'll talk more about this config directory later, but for now, this video is already going to be a bit too long. So here's the command we're going to use. We're going to say cp org.corecontrol.corecontrol desktop, and we're going to use tilde, which is short for our home directory, which is basically the same as saying /home/user in my case, but we're going to do tilde /.config/autostart/ and that's going to put this file into our auto start directory. So if we execute this command, we see we don't have any errors. If we change into that auto start directory, we'll see there's that desktop file. Now to prove that this did the exact same thing as the KDE auto start, we can open up the system settings again, scroll down to auto start, and if you'll remember, we deleted that entry from the auto start menu. We click on it, look at that, CoreCtrl's back in here. So this is a bit more of an advanced way of doing it, but as I said, both options will do the exact same thing. So the last thing I want to very briefly mention is once again related to X11 performance enhancements. So if you followed this guide so far on Wayland, feel free to skip past this section. Both NVIDIA and AMD GPUs can benefit from adding some configuration files to X11 that can improve issues with screen tearing and marginally improve GPU performance. Now, I have an AMD GPU, and so this is mainly what I'm going to be speaking on. If you have an NVIDIA GPU, I would highly recommend looking at this link here, as this can tell you how to fix screen tearing issues with NVIDIA cards, but I don't feel like I'm educated enough to just directly tell you how to do this on NVIDIA. So for AMD GPUs, we're going to create yet another X11 configuration file. So to do that, we're going to do sudo nano/etc/x11 xorg.config conf.d/20-amd-gpu.conf. Now, once again, this path and the contents of this file are available in the Arch Linux wiki under the AMD GPU page. So if you run into any issues, I would refer to this. However, there's really not much to do here. So let's go ahead and open that file, and we're going to add the following contents. So basically what this configuration file is going to do is it's going to disable some options that can interfere with the drawing of frames and can potentially lead to screen tearing in games or even just on your desktop. So once you've entered these values into the file, we're just going to go ahead and save it. Once again, with Control O, enter Control X, and that's all we're going to do for AMD GPU. Now for NVIDIA GPUs, once again, I'm not going to go through exactly how to do this, but essentially you're going to do a similar thing. You're going to generate an xconfig file, which is specific to your NVIDIA GPU. You're going to copy that configuration file into a configuration file like I just did for the 20-amd-gpu.conf. You'd probably copy it to 20-nvidia.conf or something like that. And then the options you're going to enable are going to help with screen tearing, but also this is where you would change settings to enable overclocking for your NVIDIA GPU. Now for AMD GPUs, we're also going to enable overclocking. I'm not going to show you how to do it. I'm just going to show you how to tell Linux to enable the ability to overclock. So to do that, we're going to once again go back into our grub configuration file, which is etc default grub, and we're going to go to the grub cmd line linux_default, and in between log level and quiet, which are the only two entries that I have in here, we're going to add the following entry, and that is AMD GPU.pp feature mask equals 0x FFFFFFF 8Fs. So basically this is going to enable overclocking every aspect of your AMD GPU and is necessary if you actually want to overclock anything. So once we've got that done, we can save the file and close out of it. And once again, we've made changes to our grub configuration, so we're going to have to regenerate it. grub-mkconfig-o/boot/grub/grub.cfg. And so now when we reboot, we'll be able to overclock our AMD GPU. Now, if you're very interested in overclocking your AMD GPU, once again, you can use CoreCtrl for this, or you can use another program that I personally use called AMD GPU Clocks. You can look up the GitHub page on Google, but basically that will allow you to automatically overclock your AMD GPU every single time you open your computer without having to open CoreCtrl at all. But once again, I'm not going to be going over how to do that or how to overclock. I just wanted to mention it for those of you who want a little bit more performance and want to avoid using something like CoreCtrl for whatever reason. All right, so now we've finished completely optimizing our Arch Linux for gaming or for any CPU or GPU intensive applications. We've also installed an overlay that'll allow us to view our performance in any of these applications. And we've added some little tweaks here and there based on our graphics cards that can maybe make things a little bit smoother. This video is already long enough, so I'm going to try to keep this outro pretty short and sweet. If you have any other tweaks or performance recommendations that I missed in this video, feel free to comment them down below. With this video series especially, I really want to take into consideration all the comments and if you guys have any helpful tips or tricks, because we're all on this together. In the next video, we're going to be looking at advanced audio configuration using Pipewire and WirePlumber. In that video, we're going to be looking at how to separate our audio into separate virtual channels, how to add filters to those channels, and how to set them up with different recording software or with other software like Discord. So if you're interested in that, stay tuned for that video, and I'll see you in the next one. Have a good night, guys.